Here's an interesting problem. If you're given an array, or a linked list, can you create a zigzag of the elements in there? So let's just say question. I've got it in the clip. Okay, so like if you're given a linked list in this case, rearrange the node values such that they appear in alternating, meaning you start with low, high, kind of like that. And the example is given here where you have 1, 2, 3, 4, 5, 6 to 7. And then the low high will be 1, 3, 2, 5, 4, 7, 6. So 1 is less than 3, 3 is greater than 2, 2 is less than 5, 5 is greater than 4, and you keep going. And then can you make it alternate instead of starting with the low one, like in this case 1, you start with like 2. So like it'll be 2, 1, and then the pattern continues like that. So I'm going to do this in multiple languages. I'm going to start with Python, JavaScript, then Java, C++, and then I'll recreate the whole linked list using C, and then do the whole process again, just from pure memory pointer stuff. But I'm going to split these videos up into several videos. So I'll put all the links in there. You can watch whichever one you want. If it's just one JavaScript, you can do that. If you want Python, you can go to that video. Anyway, this was the introduction. One thing I'm going to do is, since the implementation of a linked list is just that, I'm going to treat this question as an array. This list, I'll treat it as an array, and then you can just transfer that into a linked list or do whatever operations you want. But the basic gist of this question is the fundamental logic underlying it. And that's the reason I even like it, is because of lately I've been getting into beat manipulation, and I'm enjoying that. And whenever I came across this question, because of flipping high, low, it's like zeros and ones, that kind of logic was like, oh, that's interesting. So because of that, I was excited about this question, and it's been on my mind, and I wanted to share that with everybody. All right, so let's see. How do we solve this? Let me talk about that first. We kind of want to compare like one element with the next one, or the next element with the previous one. And then we are going to have a strategy to where if we want the first one to be low, in this case 1 and 2, we know that these are in order. But when we come to 2 and 3, we know that 3 has to be, like this position has to be smaller than the previous position. So we're going to swap these two. How are we going to keep track of that? And then we know we are always flipping high, low, high, low. We can maintain that flipping by keeping track of a flag. We're going to call it a true. If we start with a true flag, that means, okay, we're going to define these rules. And then once we define them, they're going to work according to our definitions. The strategy I'm going to employ here is, I'm going to say my strategy. I'll say I'll keep track of a flag, and the flag is going to either be 1 or 0. In this case, it's true or false. And then I'm going to compare adjacent elements. And depending on what the flag is, I'll just do the opposite. I'll either swap them or not swap them. So these are the rules I'm going to expect. So let's say if we stated that the flag is true, so if flag is true, then we expect that the element, the next element, which is like, if you're looking at, well, by the way, because it just depended on how you're going to do it, I'm going to start with the second one and then always look back one more time so that when I reach the end, I can just check one last time and the whole thing would have been checked. So I will do which is current. If the current is, if the flag is true and current is greater than the previous, then we are good. So this is how I'm going to define now my rules. If the flag is true, expect current to be greater than previous. And then else, flag is false, expect current to be less than previous. And from this definition, so we know that if we are starting with a true flag, then the next one, which is the one we're looking at, should be greater than the previous one. So this is going to establish the low, high scenario. But if we want a high, like this one states, we're going to start with a flag of false. And here it says if the flag is false, we expect the current one to be less than the previous one. So then the previous one will be higher. So we're going to start with high to low, high to low. So once we establish this definition of our rules, and by the way, if either one of those are false, we're going to swap elements. So with this definition, we can establish the same thing in any of these languages. And I'll do the same thing in multiple languages just to show you that the logic is literally here. And if you want to see the implementation of this, check out the languages respectively. You can check them all, or just whichever one you want to check. See you in the next video.